Hello everyone, welcome to today's session. I'm excited to introduce our topic, Jetpack Compose Interview Guide. This guide is perfect for beginners, focusing on common questions and answers. In this presentation, we'll cover key concepts, typical interview questions, and helpful tips to prepare you. So let's get started and make your journey into Jetpack Compose a lot easier. So let's dive into what Jetpack Compose actually is. Jetpack Compose is Android's modern, declarative UI toolkit designed for building native interfaces. Now, what does that really mean? Well, unlike the traditional system we used before, which relied on XML layouts, Compose allows us to create our UI directly in Kotlin code. It uses something called composable functions, which are Kotlin functions that describe our UI components. For example, you might see a function like a composable fun greeting, which takes a name and displays a greeting message. The beauty of this approach is that Compose automatically updates the UI whenever your data changes, so you don't have to manually handle view updates like you did with the old system. To give you a quick example, if you write a composable function that shows some text, like a greeting, Compose handles all the behind-the-scenes work of creating and updating the UI for you. This makes building interfaces more intuitive, more flexible, and much more aligned with modern programming practices. It's a big step forward in making Android development faster and more enjoyable. So let's talk about how Jetpack Compose differs from the traditional view system. The key difference is that Compose uses a declarative approach, while the old system is imperative. In simple terms, with Compose, you describe what the UI should look like for a given state, and it takes care of updating the screen automatically whenever that state changes. This means you no longer need to work with XML layouts or call FindViewById, which were the common practices before. Instead, you just call composable functions directly to build your UI. Compose also handles nested layouts very efficiently, which is a big improvement. In the traditional system, deep view hierarchies could become quite heavy and impact performance. Compose, on the other hand, manages these nested layouts more smoothly, reducing those costs significantly. As one guide puts it, Compose handles nested layouts efficiently, which is a big improvement from Android views. Overall, this shift to a declarative style makes UI development more intuitive, flexible, and performant, aligning well with modern app design principles. So let's talk about what a composable function is in Compose. Essentially, it's a Kotlin function that we annotate with at composable. This annotation is really important because it tells the compiler that this function is meant to build a piece of user interface. Instead of returning UI elements like traditional functions, composable functions directly emit UI components. For example, if I write a composable fun simple text, hello world, this creates a piece of UI that displays hello world. The key point here is that the composable function's role is to describe a part of your UI, not just generate data. Composable functions can take data as input parameters, and then use built-in UI elements such as text, row, or column to lay out your content. They can also call other composables, forming a hierarchy or tree of UI components. As the official documentation describes it, a composable function is like a function emitting a unit that describes some part of your UI. It takes some input and then generates what's shown on the screen. Understanding this is crucial as it ties into the overall theme of Compose, building UIs in a more declarative, intuitive way by describing what you want, rather than managing every UI state manually. So, what exactly is a modifier and how do we use it? Well, a modifier is basically a collection of layout or drawing instructions that you can apply to a composable. Think of it like layout parameters or style attributes in XML. It's a way to customize how your UI elements look and behave. For example, you might use modifier padding to add space around your element or modifier fill max width to make it stretch across the available width. And the cool part is you can combine these modifiers using dot chaining. The modifier interface itself represents an immutable, ordered list of these elements, things like padding, click listeners, backgrounds, that decorate your composable. For instance, if you have a text composable that says hello, you can add a modifier like this. Modifier, padding 16 dp, background color, blue. This code applies padding and a blue background to that text. You can keep chaining as many modifiers as needed, which gives you a lot of flexibility. In essence, modifiers let you fine-tune your composable's layout, appearance, and behavior, all in a clean, declarative way that aligns perfectly with the overall theme of building flexible, responsive UIs. Now let's look at some basic layout composables and understand their purposes. First, we have the row. As the name suggests, it arranges its children horizontally, placing them side by side. This is useful when you want elements to appear in a line, like buttons or icons next to each other. Next, there's the column. Think of it as stacking elements vertically, one on top of the other. For example, if you want to display a list of texts or images in a vertical sequence, column is your go-to. You can also control the alignment and spacing within a column using parameters, making it very flexible. Then we have the box. This one is a bit different because it stacks its children on top of each other, which is perfect for overlaying content. Imagine putting a label or an icon over an image. That's where box shines. For instance, if you write a simple column with two text elements, like A and B, the A will be above the B. This shows how vertical placement works. These composables are powerful because they help us arrange most UIs efficiently, and Compose is designed to optimize their performance. Remember, use column for vertical layouts, row for horizontal, and box when you need overlaying. They form the foundation of building flexible, organized interfaces in Compose. So let's talk about what state really means in Compose and how it influences the user interface. Basically, state is the data that determines what UI is displayed on the screen. Now, Compose functions are, by default, stateless, which means they don't hold any internal data. Instead, they show UI based solely on the inputs or parameters they receive. When the state changes, Compose takes care of the rest. It automatically recomposes or redraws the affected parts of the UI. Think of it this way. Any change to an observable piece of state, like a mutable state, triggers a rerun of the composable functions that read that state. So, the UI updates seamlessly without you having to manually refresh anything. For example, if you create a state variable like using var name by remember mutable state of, when the value of name changes, Compose notices this change and schedules a recomposition. This is what we call a declarative model, where you simply update the state variable, say name equals hello, and the UI automatically reflects that change. As the official docs say, Compose is declarative and the only way to update it is by calling composables with new arguments. So, whenever the value changes, it triggers a recomposition for any composable that reads that value, ensuring your UI stays in sync with your data. This approach makes building dynamic, responsive interfaces much more straightforward and intuitive. So, how do you store or remember data across recompositions? Well, the key is to use the Remember API. When you call Remember, inside a composable, Compose will keep that value around even when the composable recomposes. For example, in our counter composable, we declare a count variable that uses remember with mutable state of. That way, the count value is stored in the composition itself and survives any recompositions of counter. Every time the composable recomposes, remember returns the stored value instead of rerunning the initializer. This means the count value persists as long as the composable is in the UI. But it's important to note that remember alone only keeps data as long as the composable is in memory. In cases like device rotations or configuration changes, you might want to use remember savable instead, which ensures your state persists across such events. So, in summary, remember helps manage state effectively during recompositions, ensuring your data remains consistent and your UI stays responsive. So let's talk about the difference between remember and remember savable. Both of these functions help us store values across recompositions, which means if the UI updates, our data stays put. However, remember by itself doesn't handle configuration changes like screen rotations. When the device rotates, the activity is recreated, and without additional handling, the stored data using remember can be lost. That's where remember savable comes in. It does everything remember does, but with an important extra feature. It survives configuration changes. It saves the state to a bundle, so when the activity is recreated after a rotation, the value is restored seamlessly. For example, you might write var name by remember savable, mutable state of. This ensures that your input or state remains intact even if the user rotates the device. The official documentation notes that while remember is great for retaining state during recompositions, it doesn't retain that state across configuration changes. For that, remember savable is the recommended choice. So, in the context of building resilient, user-friendly UIs, understanding when to use remember versus remember savable is key. It helps us manage state effectively across different scenarios, ensuring a smooth user experience. So, to preview a composable in Android Studio, you need to annotate it with both at composable and at preview. This combination is key because at composable indicates that the function defines a UI component, while at preview tells Android Studio to generate a visual preview of that component. For example, you might have a function like greeting preview that calls your greeting composable with a sample name, such as preview. When you do this, Android Studio will automatically render greeting preview in the design view. What's really helpful here is that the preview updates live as you make changes to your code, so you get immediate visual feedback without needing to run the app on a device or emulator. The official documentation emphasizes that the at preview annotation is what signals Android Studio to display the composable in the design view. And because of this setup, you can see real-time updates to your UI as you tweak your code, making the development process faster and more iterative. This capability ties into the overall theme of making UI development more efficient and interactive, allowing you to see your changes instantly. So, what exactly is Material Theme in Compose? Well, it's a composable function that applies material design theming to whatever content you put inside it. Think of it as a container that holds your app's color schemes, typography styles, and shapes, ensuring a consistent look and feel throughout your application. When you wrap your UI components in Material Theme, you're effectively telling Compose to style everything inside according to your chosen theme settings. For example, you might specify your color scheme, typography, and shapes like this. Material Theme, color scheme equals light color scheme. Typography equals typography. Shapes equals shapes. Now, according to the official documentation, Jetpack Compose implements material design 3 concepts through this Material Theme composable. That means by defining your color scheme, typography, and shapes, all your material components will automatically adopt these styles, creating a cohesive and modern interface. And an important point to remember is that Material Theme also supports dark mode. You can dynamically switch between light and dark themes by using functions like isSystemInDarkTheme to check the system's setting and apply the appropriate color scheme. This helps your app adapt seamlessly to user preferences, enhancing user experience and accessibility. So, in the context of our overall discussion on building consistent, beautiful apps with Compose, Material Theme serves as the foundation. It ensures your app's design remains uniform and adaptable, aligning with material design principles and modern UI standards. Thanks for reading. I really appreciate you taking the time to go through this presentation. Throughout, we've explored the key concepts and ideas that are crucial for understanding the topic. I hope this has given you some valuable insights and a clearer perspective. Remember, the main takeaway is how these points connect to the bigger picture, emphasizing the importance of applying this knowledge effectively. Thanks again for your attention and engagement.